Sorry this video took a little bit longer than I expected. Hopefully you will still have enough time to watch it. This time I don't have a template that you can print out. You'll just have to follow along with your own piece of notebook paper. You do need to write this down, not just watch the video. So today we're going to be focusing on triangles. And when we talk about a triangle, it has 6 parts. It has its sides and its angles. So we have 3 sides. If I label this triangle ABC, then I would have side AB. So that would go from the point A all the way to point B. I have side BC, going from B to C, and side CA, going from C all the way to A. So when we label the sides, we use 2 letters with a line above it to say this is a line segment. It also consists of 3 angles: angle A, angle B, angle C. Now if there's more going on in my triangle, then I would need to label my angles with 3 letters instead of 1. So if I had a couple of triangles attached together and I wasn't sure what I meant by angle A, so let's say we add this, and I wasn't sure what I meant by angle A, I would need to use 3 letters, like angle BAC. So we start at B, move over to A, go over to C, so this would be the angle that it was talking about. So when we have triangles, we want to know whether the triangles are exactly the same or not, so whether they are congruent. And there's 3 ways to show that. To show 2 triangles congruent, we can use side, 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 which we usually represent with SSS. Side, angle, side. And they put it in that order on purpose. The angle must be between the 2 sides. And angle, side, angle. Hopefully this looks a little bit familiar. It should be something you've talked about last year. So if I was given 2 triangles and I wanted to know whether these 2 triangles were congruent or not, then I could use these 3 pieces of information. If those 2 triangles had 3 sides that were exactly the same, then the entire thing is congruent. Then all 6 pieces are congruent, not just those 3. Or if I had side, angle, side, if I have triangles where we have 2 sides the same and then they share a common angle, then the entire 6 pieces are the same. For example, let's say we have a picture like this. And some information is given to you. We know side AB is congruent to side DB, and we know side EB is congruent to side CB. So we know all those pieces of information. And that's not quite enough. If we know AB is congruent to DB, so we know this first one, that means AB is congruent to DB. We put that little mark to show, hey, those are the same. Then we also know EB is congruent to CB. So again, this time we put 2 marks to show those 2 sides are the same. Excuse me. But not necessarily the same as AB and DB. But that's only 2 of the sides. We don't know anything about the 3rd side, and they didn't actually give us information about the angles. But knowing what we know about angles, we know that angles across from each other, or vertical angles, are the same. So those two angles that I've marked in red are the same. You can either just put the mark like that, or sometimes they put a mark with a line to show that those two angles are the same. So that information we had to know ourselves, and now we have a side, an angle, and a side. So we could say these two triangles are congruent by side, angle, side. So we could say triangle A, B, E is congruent to triangle D, B, C, oops, I forgot my triangle symbol, by side, angle, side. So again, this should look familiar. It should be something you've seen a little bit last year. Something else that should look a little bit familiar is the Pythagorean theorem. Okay. The Pythagorean theorem only works for right triangles. It doesn't work if we just have any old triangle. It only works with right triangles. So if we have a right triangle, again we're going to label this ABC, but the Pythagorean theorem deals with the sides, not the angles. The A I've labeled is the angle that goes on this point, so this angle. But the side across from it we would label little a. The side across from B would label little b. Side across from big C we'd label little c. So Pythagorean talks about the sides, and it says if you know two of the sides, you can find the third. And it uses this formula, a squared plus b squared equals c squared. So it's saying if you know two sides, you can find the third. So let's say we have this right triangle and we know that this is 13 and this is 5 and this we don't know. We're going to call it x because we don't know it. Well, we can apply the Pythagorean theorem, but it's very important that we know which side is the hypotenuse. The hypotenuse of a triangle is the one across the side across from the right angle. So in this case, C is your hypotenuse. Now my triangle right here is in the same orientation, but what if I rotated it? What if my triangle was like this? Well, then we'd see C is actually across in that direction. But we know 13 would be C, so A and B, it doesn't matter. We can put them in any order. But then we go plug it into our formula. We know a squared plus b squared, but we said b is represented by x, equals c squared, and we said c is 13. So now we'd have to go through and simplify this. We do 5 squared, which is 25, 13 squared, which was 169. And then we have to solve this equation. So this is a quadratic because it has a squared. Because it's squared, it's quadratic. But it doesn't have an x term, it just has one x squared term. So we can solve this by square roots. We can minus 25 from both sides. (169) minus 25 is 144. And then to take care of squared, we square root both sides, which cancels out the squared and the square root. Now when we were solving with square roots, we always put the plus and minus in front to say, well, square root of 144 is 12. To say, well, we really have a positive 12, we have a negative 12. But we are working with an actual shape. And on that shape, we can't have a negative distance. So we get rid of the negative value and just say x is positive 12. So the last thing we want to talk about with triangles is some parts of the triangle we can draw in. There's a couple of definitions we need to know. The first one is altitude. The altitude in a triangle is a line segment from a vertex perpendicular. When we say perpendicular, we mean at a 90-degree angle, perpendicular to the opposite side. So let's say I have any random triangle. And again, I'm going to label it this time. Let's do XYZ. It doesn't have to be ABC. So an altitude is a line segment from a vertex. When we say a vertex, we mean one of these pointy parts. So that point perpendicular to the opposite side. So I can't just draw a line anywhere because that's not necessarily at a right angle. We want this to be at a right angle. So specifically, I want it to go straight down at a right angle. Now we could do this from any side. I don't have to come straight down from the Y. I could start at the Z. This one's going to be a little bit harder to see where the right angle would be. And it helps if you have like a ruler and stuff, which I do not. So we can draw an altitude from any of the vertexes. A second line we can draw in a triangle is called a median. And a median is a line segment drawn from a vertex to the midpoint of the opposite side. Now midpoint is exactly what it sounds like, the middle point of a line segment. Now again, this works for any triangle. So I'm going to draw a random triangle. Let's label this one ACT. So if we're drawing it to the midpoint, we're drawing from a vertex, let's pick vertex A. And if we're going to a midpoint, we would need to know where's halfway on this line that's opposite from that vertex. So halfway, which right now we just have to guesstimate. We're going to learn ways to find it exactly, but right now we're going to guesstimate. And if we know it's exactly halfway, that means we know from C to the point in green and from T to the point in green are the same. So I'm going to put those marks to show those are the same. So that is a median. This line in green is the median. So 2 more definitions, and then you will be done with notes for today. Angle bisector is our next line we can draw in a triangle. So angle bisector. Bisector means we're cutting something in two, like bicycles have 2 wheels. So an angle bisector is cutting an angle in 2. And specifically, we don't want to just cut it into 2 random pieces. We want to cut it exactly in half. So an angle bisector is a line segment drawn from a vertex that cuts an angle in half. This time we don't even care how it hits the opposite side. It doesn't have to hit it halfway, it doesn't have to hit it at a perpendicular angle. We just want it to cut the angle in half, and then it'll hit the other side wherever it happens to hit the other side. So again, random triangle. Let's do one like this time. And let's label it ABC again. So this time we're focusing on the angle that is associated with the vertex we're going to draw from. So we want to cut that angle exactly in half. So again, we're just guesstimating right now. I'm guessing the midpoint's about there. So these two sides of the angle would be the same. And we would draw our line straight through that midpoint. And again, we don't really know any information about A to where the line hits the other side and about C to where the line hits the other side. We don't know anything about those sides. We're focusing on that angle. So then we have one last definition. That is a perpendicular bisector. So again, perpendicular means it's at a 90-degree angle. Bisector means we cut something in half. This time we're going to cut a side in half. So a perpendicular bisector is a line drawn perpendicular to a side of the triangle through its midpoint. This time we're not going to focus on an angle or a vertex at all. It doesn't say anything about the vertex. It only talks about the side of the triangle. So again, we're going to draw a random triangle. Let's call this one XYZ again. So this time we're going to focus on the side. Let's focus on the side XY. So it said we're drawing a line perpendicular through its midpoint. Again, we are just estimating right now so we can get these definitions. We will learn how to find this exactly. So I'm going to estimate this midpoint is about there, and we want to draw a line perpendicular. So we can't draw it at an angle, we need to draw it perpendicular. So it doesn't matter where it hits the other side, we just know for sure it's perpendicular to the side XY. And we also know that it cut line XY in half. When we get to actually drawing these correctly instead of estimating, we will be using compasses. Compasses are a great tool in geometry that will help us find these lines exactly and draw perpendicular lines exactly, draw angle bisectors exactly. So again, I'm sorry it took a little bit longer to get this video online, and I will see you guys tomorrow.